So now you can see this, I hope. Yeah. So P of n, right, is just this entire statement up top. And so the base case we're going to consider here is, let's consider n is equal to 0. Then P of 0 is, sorry, not 0. Our first base case here is 1, right? So the first positive integer, the smallest positive integer is 1.
Is 0 considered a positive integer?
0 is not a positive number.
Oh, okay.
It would be considered a non-negative number, so that's why we considered it in the one that, yeah, for the derivative one, we had non-negative ones. But here, we're going to start with a positive integer, so that would be, that's like natural numbers, another way of saying the natural numbers, so that would be 1. So then P of 1 is just the statement. On the left side, I would have 1, and on the right side, I should have 1 plus times 1 plus 1 over 2. That does equal 1. So that takes care of the base case. And I'll just say, that's usually what's really nice about induction. If you're finding it really difficult to prove the base case, induction might not be the best method. But what happens is that the base case is easy to go, and then we see that there's some iterative process, then that sets us up really nicely for induction. And when you're writing these proofs on homework, I do want to see things written out like this way. Like, it should be labeled what is the base case. It should be labeled what's going on in the induction step. And so for the induction step, it's always going to be the same thing. I'll just say the hypothesis So this inductive hypothesis is always going to be for all values of k bigger than or equal to our base case less than some integer n, we're going to assume that P of k is true. And that's the induction hypothesis always in induction, and we just need to replace in what is P of k. That's really the only thing we need to identify is what's the base value and what is statement P of k. And we've already identified both of those things when we did the base case. So here we're going to say, let's let k if you want to get descriptive, it should be an integer. Okay, and what's significant about the 1 there, remember that was our base case. And that's what statement P is when I plug k into it. Okay, and we want to prove the same exact thing is true for values bigger than k. So as far as what I was asking you to do in your groups, this was the task here. Any questions about that?